Okay, chapter 3.9, subtract decimals. This is very much like yesterday's lesson 3.8 on adding decimals. It's also stuff that you're used to doing that you probably remember how to do from last year. Um, at least you know how to subtract. You may not have done it with decimals before. And the only thing we need to watch out for is regrouping, which is sometimes called, and you might have heard it called, as borrowing. Okay, for instance, if you have um, this number, 0 and 23 hundredths, and you're subtracting 18 hundredths from it, you've got a little problem. Now 23 hundredths, remember, looks like 2 sticks plus 3 dots, okay? And 18 hundredths looks like 1 stick and 8 dots. Okay, so we're subtracting. We can't take these 8 away from these 3. It doesn't work because there are more of them. So we have to borrow or regroup. So we're going to regroup. We're going to change the 23 into a 10, 1/10, and 13 hundredths. And the way we do that is by taking this 10 right here, and we get rid of this 10, and we rewrite it as 10. This is 10 hundredths. So now we have 10 and 3. That's 13 hundredths. So we took away from the tenths place and regrouped it. We took a tenth and broke it into hundredths. So now we have 13 hundredths. And I know that you've seen this in subtraction before. We call it borrowing, or we call it regrouping. But I need to make sure you understand the process that's actually happening. And this is why the pictures that we did last week help us with that. So now instead of being 23 hundredths, it's still 23 hundredths, but it's 1/10 and 13 hundredths. And we're subtracting 18 hundredths from it. And you can take 8 away from 13. It actually ends up being 5, right? So if we were to take 8 out of here and 8 out of here, it leaves us with 1, 2, 3, 4. There's a little guy up here. 1, 2, 3, 4. It leaves us with 5. 13 take away 8 is 5. And then 1 take away 1 is 0. And we're just left with that. And you know that 23 take away 18 is 5 anyway. So that's the long and the short of it. And we'll just do a couple problems just to show you. They still want us to estimate. For instance, if we have 13 and 54 hundredths, and we're subtracting 6 and 7 tenths. Okay, we've lined everything up. Our ones places are lined up. Our tenths places are lined up. We don't have a hundredth, but we can add it. We can add that 0 in just to fill up the place values. And we're subtracting. Now they want us to estimate, so we might say 14, because 13.54 rounds to 14, minus 7. Because 6.70 rounds to 7. And 14 minus 7 should be 7. And that's probably the best way to do it. The other way is to use those benchmarks, okay, that they taught you about on one of the other lessons. The trouble with benchmarks is that here the benchmark is at 50, and this benchmark is at 75. And you can't quite take 75 away from 50 without borrowing. And so this isn't quite mental math anymore. So the benchmark doesn't work as well. It still works. You just have to make this $1.50, 150, take this 1 and change it into another 10 tenths. So 150 minus 75 is 75. And then 12 take away 6 is 6, so 6.75. I think we did that right. Okay, so nonetheless, sometimes rounding is best, and sometimes those benchmarks get us a better answer, and we can still do it in our head. This case, you can't, so rounding is the best. 14 take away 7 is 7, and our answer should be around that. It might be closer to 675. Anyway, we're going to just start by subtracting. 4 minus 0 is 4. 5 minus 7 doesn't work, so we're going to have to regroup. We're going to take a 1, change it into 2 ones, and move one of them over here as 10 tenths. So this becomes 15 tenths. All right, so this brown color is to show that these are all the same place value. We had 5, and we added 10 to it, and so it makes 15. We added 10 tenths because we changed a 1 into tenths, and there are 10 tenths in 1. That makes sense. I know you guys get this. So 15 take away 7 is 8. Bring our decimal straight down. Maybe change back to the blue color if I can figure out which blue it was. Again, I can't take 2 away from 6. So I guess maybe we'll do it like this. So we're going to change this into a 0, change this into 1, but I can take 6 away from 12. And 12 take away 6 is 6. So 6.84 is the answer. And if you look over here, 7 was a good estimate. 6.75 was a better estimate. And estimates aren't supposed to give us the exact answer. They're just supposed to be something quick and easy in our head, which is why this one up here is the best one. It's the best estimate for us. And our answer is 6.84. Now, the lesson mentions that sometimes it's easy to check your work by adding the thing that you're subtracting, 6.70, and your answer. So your difference. So this is the difference. This is what you're subtracting from 1354. And if we add those back together, if we just want to check our work, we can. And we can do this without borrowing. So 0 plus 4, 7 plus 8 is 15. Carry the 1. 6 and 6 is 12, plus 1 is 13. So 1354, and that's what we had. So we must have done it right. Okay. That's all there is to it. Oh, there's one where they have an n. And I just want to show you that there's, for instance, if we have 3 minus 2 equals n. Oops. 3 minus 2 equals 1. Okay. Obviously enough. Let's try a different one. 8 minus 3 equals n. What does n equal? Well, n has to equal 5. Okay, because 8 minus 3 is 5. And since it's also n, then n and 5 have to be the same. And if we put 5 in here, it would still work. 8 minus 3 equals 5. We can go backwards. 5 plus 3 equals 8. Moving back in the other direction. Excuse me. Now they give you some of these problems a little differently. They might say 9 minus n equals 3. Well, what does n equal in this case? N is not 5 anymore because 9 minus 5 is not 3. 9 minus 5 is 4. So n has to be 6. So n equals 6 because if we put a 6 in here for n, then 9 take away 6 equals 3. And 3 plus 6 equals 9. Okay, so n can be anything. It depends on the problem. This time n was 5. This time n was 6. And if we do it another time, we might get another answer for n. Okay, so here's another one. N minus 3 equals 4. Okay, so what does n have to be? Well, remember, you can go backwards. Remember we did 3 plus 6 equals 9. 9 minus 6 equals 3. So we can just go backwards. 4 plus 3 equals 7. So n must be 7 because then if we put 7 in for this n, 7 minus 3 is 4. Okay, that makes sense, right? So there's a couple problems that are similar to that. Like they might say 3.24 minus 1.05 equals n, or they might say n minus 3.54 equals 4.09. And you have to figure out how to solve for this. They might also say the other one that they might do is 12.07 minus n equals 7.51. Okay, so this one is maybe the hardest one, but the truth is that if you add this to this, to n, you get this. But if you subtract 1207, let's do it this way. If you go 1207 minus 751, you are going to get whatever n is. Okay, so you can skip over and come back. You can see how that works. For instance, let me show you a quick example. Say we just did 12 minus n equals 7. Well, then what would n have to be? If we did 12 minus 7, we would get 5. So 12 minus 5 does equal 7, and 7 plus 5 equals 12. So again, you can figure out a separate type of subtraction problem to get your answer with these. And there are a couple of problems where you have to do that on the assignment. It's the algebra portion of the assignment. There's 3 problems, and they look just like this. So make sure you watch this maybe once or twice so that you're ready for that, or come and see me and I'll help you. Okay, that's it for today, unless you want to stick around and watch me make a silly picture. I was pretty careful. I went outside again today, and I was kind of worried about my experience that I had with the snail. So I went outside. Let's see how this turns out. You know, when I do this with a pencil, I can erase. And it's nice to be able to erase sometimes. And when I do this with this tool, I can't see exactly what I'm doing. It's a little bit harder, and so sometimes things don't turn out. Alright, yeah, see that my glasses kind of look crooked, but I have a nice, that's sort of a silly smile. The way I drew the mouth, I don't think there's any way to do it better. Alright, well, I was visiting my backyard again, and I was kind of worried because I'd run into that big snail. And so while I was outside, this is the part you need to pay attention to. I was outside walking along like this. I made sure that I wore my big shoes because I was worried about that snail. And then, so there I am wearing my really big shoes, and I'm walking along on my back porch, just happy as can be. See, I got a grin on my face, kind of looks a little silly, but there it is. Walking along because I'm not afraid at all of that snail, and you know what I saw? I saw my little friend the snail. And he was only that big. Yesterday he was huge. I'm not sure what happened. I have no idea. So, do you think I squished that snail? I thought about getting out a giant salt shaker and shaking salt all over him. See, this is what would happen to him if I had a big salt shaker. Then he would be in trouble for sure. Okay. But I didn't do that. I was tempted. Because have you ever seen what that does? Yeah, thought so. I didn't do it. I just took a leaf and I put him in the grass. I was very kind. Talk to you later.